L'Hopital's rule, that's when we are talking about all the different indeterminate forms. What are they? Okay, so we had this whole like list. The 1 to the infinity is an indeterminate form. We also had 0 to the 0 and all of those, what was our strategy on those? And then at the end, we add e to the answer. All right, so then we also had infinity minus infinity. And what do we do on those? So we got a common denominator. And then from there we could do the L'Hopital's rule. We had 0 times infinity. So we had to rewrite as a fraction. And then do L'Hopital's. And remember, L'Hopital's is, if we're going to do that, it has to be 0 over 0 or infinity over infinity. Those are indeterminate forms, but those were the one where we could go straight into L'Hopital. So this is like the main one, 0 over 0 or infinity over infinity. If it's any of the other indeterminate forms, we have to rewrite it so it's like this, and then we can do our L'Hopitals. So if we're looking at these, first we have to see, do I even need L'Hopitals? Is this something I can evaluate? So on A, we have the limit as x approaches 0 of 5x. 5 times 0 is 0. E to the 0 is 1. 2 times 1 minus 2 is 0. So 0 over 0 is an indeterminate form. So I asked you to write the LH so I know that you're doing L'Hopital's. And what does L'Hopital's rule say? Right. This is separate from doing the derivative of the whole thing. It's not a quotient rule. It's just derivative of the numerator over derivative of the denominator. Now if I evaluate, the top is still 5. The bottom, 2 times, what's e to the 0 power? 1. I'm going to get 5 halves. Is that okay? So B, we have the limit as x approached infinity of x to the negative 4 natural log x. So if I look at this, we have x infinity to the negative power is like 1 over infinity, so that's going to 0. Natural log of infinity is going to infinity. 0 times infinity, that's an indeterminate form. Can I do L'Hopital's as it's written? No, it has to be that fraction. So our strategy was to move one of them to the denominator. Now you're not just like throwing it on the bottom. It has to be mathematically equivalent. Which one would be easier to move to the bottom? Right, a negative exponent means it goes to the bottom anyway. So then it would just become a positive. Okay, so notice, these things are equivalent. They're the same. So the natural log of infinity is infinity. Infinity to the 4th is infinity. So if it's infinity over infinity, now we can do L'Hopital's. Derivative of the top. What is the derivative of a natural log? Over derivative of the bottom. 4x cubed. Strongly recommend simplifying as much as you can. Different options here, but would it be legal if I just took both the top and the bottom times x? So 1 over x times x is 1, and then this would be 4x to the 4th. So now we have 1 over 4 times infinity, which gives me 0. 1 over infinity is 0. Is that one okay? C. we have the limit as x approaches 1 over x minus 1 minus 1 over the natural log of x. So if I plug in my 1, I have 1 over 0, or 1 over a smaller and smaller number, which will go to infinity, minus 1 over the natural log of 1 is also 0, so 1 over a smaller and smaller number. So this is currently infinity minus infinity. So we can't do that. What am I going to do? Right. Somehow I have to get these to be a single fraction so we can do L'Hopital. So that's our common denominator. So I'll take the first one times natural log x on top and bottom. Second one times x minus 1. So I get the natural log of x. Can I distribute a negative 1 so it makes it minus x plus 1 all over x minus 1 natural log of x? Okay, natural log of 1 is 0, minus 1 plus 1 is 0, and then 0 times 0 is 0. So now it's 0 over 0, which means L'Hopital. Derivative of the natural log is 1 over the argument, minus derivative of x is 1, plus derivative of 1 is just 0, so that's gone. What do we have to do on the bottom? We have to do product rule. Even if you multiply it out, we'll still be stuck with the product rule, so either way. Derivative of the first times the second plus the first derivative of the second. Derivative of the natural log is 1 over x. Clean it up. Don't try to just look at this and identify the answer yet. And if I distribute that 1 over x, I get 1 minus 1 over x. Is this nice? What could I do maybe now? Yeah. Okay, we can't just necessarily flip and multiply, but we could do like we did on the last one where we just said let's take top and bottom times x, so that we don't have quite so many fractions. So we get 1 minus x over x natural log x plus x minus 1. Alright, 1 minus 1 is 0. 1 times 0 plus 1 minus 1 is 0. So what does that tell me? L'Hopital's again. Derivative of 1 minus x. Right. For the derivative of the x natural log of x, we have to do product rule. Derivative of the first times the second plus the first derivative of the second plus derivative of x is 1, derivative of 1 is 0. So now on top we have negative 1, natural log of 1 is 0, plus 1 plus 1 is 2. So we get negative 1/2. Questions there? Last one. Limit as x approaches 0, 2x plus 1 to the 1 over x. So 2 times 0 plus 1 is 1. 1 over a smaller and smaller number is going to infinity. Is 1 over infinity allowed? It's an indeterminate form. How do we deal with these exponentials? Adding natural log. Okay, the reason we do that is properties of logs. What happens to that exponent? So that turns into 1 over x times the natural log of 2x plus 1 Or we could write it as the natural log of 2x plus 1 over x. Okay, so since I added natural logarithm, my answer will be e to some power. If I put in a 0, natural log of 1 is 0 over 0. So now it's the normal indeterminate form, so we do L'Hopital's. Derivative of the top, so 1 over 2x plus 1, but we have to do chain rule, so times derivative of the inside. What's the derivative of 2x plus 1? Over derivative of the bottom is 1. So this is just 2 over 2x plus 1. Put in a 0, so you get 2 over 1 or 2. So that means the final answer is e squared. Questions on this? So I have a handout. So I tried to go through and identify the key topics, and we'll do a little bit of review on each of those, unless you guys have any other questions on that study guide first. So if you're trying to do some studying later, like I know you guys all do, you would want to look back at this. It kind of breaks everything down. The first ones are the L'Hopital's. Why don't we come back to those since we just did some? That way if we run short on time today, we've gotten through everything else. Let's go to number 5, optimization. So we have to write an equation with one variable. Then we can do our derivative and solve from there. So a theater seats 1,000 people. If the ticket price is 15, then the play will sell out. For each increase of $1 in the ticket price, 50 less tickets will be sold. What price should be charged in order to maximize the revenue? All right, when I'm first looking at this, I noticed this $15 is talking about the price. So this ordered pair is for my price function. So my price is the function, so the price has to be the x or the y. The y. So that means the first one, my x was 1,000 tickets, and the price is 15. So my order pair is like the number of tickets, the y is the price. Okay. If I increase my price $1, 50 less tickets will be sold. So if I charge $16, how many tickets would I sell? What do we need to do here? Find our slope so we can write the price function. y2 minus y1 over x2 minus x1. So we get negative 1 over 50. Plug into y equals mx plus b. And get a y-intercept of 30. So my price function, because these order pairs were for price, so the equation we have is the price function, is negative 1 over 50x plus 35. Everybody understand how we got that? So next, what am I trying to maximize? The revenue. How do we find revenue? Revenue is the amount of money you bring in. So it's the number of tickets you sell times the price of a ticket. So x times p of x. So my revenue will be negative 1 over 50x squared plus 35x. What do we do now? That's negative 1 over 25x plus 35, and we set our derivative equal to 0 anytime we're trying to maximize or minimize. So multiply over, and we get x to equal what? 75, is that right? Is that the question? No, I asked for what price. Kind of running out of room here. So we have a price function. We need to plug the 875 into that. So negative 1 over 50 times 875 plus 35, and that gives us what? 1750. So we will bring in the most money if our tickets cost $17.50 each. Questions on that? Let's go into our summation rules. What is the rule for adding up I to the first? So put a big star here. You have to know these. I squared is n times n plus 1 times 2n plus 1 over 6. I cubed is and if you add up a constant, it's just your constant times n, the number of times you added up. All right. So if I ask you to add this up, coefficients just stay. My I squared formula, so my n would be 8, n plus 1 is 9, 2n plus 1, so 2 times 8 plus 1 is 17 over 6. Minus, when I add up 4, 8 times, it would be 4 times 8. So on the test, since it's like a non-calculator thing, it would probably be more me saying set up the formula, but you don't have to evaluate it on some of these uglier calculations. All right, 7, I cubed. So my n here is, so it would be 12 squared times n plus 1, so 13 squared, divided by 4. Plus 5 times my I to the first is n times n plus 1 over 2. $6,474. So could you guys do those types of problems? Know your summation rules. If you need to study something, this is the paper you should look back at. Left, right, and midpoint sums. Again, on the test, without a calculator, likely I would have you set it up, but maybe not evaluate it all the way. So, if I want you to do this, I ask you to find the right and the midpoint on this particular one. What do I need to find first? So change in x is your ending minus your starting divided by n. So that is 3/5. Okay, if you prefer working in decimal, 0.6. Either one is fine. So we have to think, like my interval is starting at 3. We're going to increase by 0.6, so the next one is 3.6. When we add these up, we always take it times the width. So the width is 0.6. So when I ask for the right, the first point you plug in is the right-hand side. Which of these is on the right? 3.6. So that would be the first one we plug in, and we have 5 total things that we're going to have because n was 5. If I had asked for a left sum, what would be the first thing you plugged in? So you're plugging it into this equation. So 2 minus 3 times x squared, and my first x is 3.6. The next one, if you add 0.6, that would be 4.2. If you add 0.6, 4.8. Add 0.6, 5.4. And if you add 0.6, that gives us 6. And we notice 6 was the end of the interval. For the sake of time, I don't think I'm going to put this in your calculator. But you guys could if you had to, right? The test, we know without a calculator, I'd probably just have you leave it like this. I also asked for the midpoint. So similar setup, the width is still 0.6. We're going to have 5 things. But we have to figure out what the first one is. The first one is in the middle. What's in between 3 and 3.6? So the first number I plug in is 3.3. And then my change in x is still the same. So the next one, if you add 0.6, would be 3.9. Add 0.6, 4.5. Add 0.6, 5.1. Add 0.6, that's 5.7. And it ends before 6, which is the stopping of my interval. So we're in good shape. So if I ask you to do a left, right, or midpoint, you guys confident you know what to do there?
So to find your over, you take the starting point and you add your change in x.
Mhm.
Okay.
All right. We should be able to use this limit to calculate the interval if I tell you to do so. So if I'm asking you to set it up like this, the limit as n approaches infinity of the sum from 1 to n. F of x sub I times the change in x. So we need our change in x. So ending minus beginning divided by n, so 6 over n. How do you get x sub I? So f of x sub I, you are plugging this 6 over n I in for the x in your equation. Times dx, which is the same as change in x. Simplify as much as you can. So if I distribute my 6 over n, I get 18 over n minus 2 times 6 over n would be 12 over n times another 6, so 72 over n squared I. Now we do our summation. Is everybody okay at that point? So we are adding up i's. That means if something doesn't have an I, what is it? It's a constant. And how do you add up a constant? Times by n. Minus 72 over n squared. And then the I formula is n times n plus 1 over 2. We have to clean up. 18 divided by n times n is 18. Let's see, 72 divided by 2 would be 36. I could cancel one of those in, so I'm at 36 times n plus 1 over n. So if I distribute my negative 36, I get 36n divided by n minus 36 over n. What happens on this one? N's cancel. So we have 18 minus 36 minus 36 over infinity goes to 0. We get negative 18. Right, you cannot, if I give you one of those and tell you to use the limit of the sum, you cannot just do the integral rules. Okay, you have to use this method and show me that. Any questions on this one? Why don't you guys take a look at the next couple, see if you know where to start. What do you do with the 3? Just bring it down. What has a derivative of cosine? Regular sign, because I want the antiderivative. Derivative of sine is cosine. Okay, so if I'm doing this derivative of sine is cosine, angle stays the same, but I would have to do times the derivative of the inside, which is 4, so to cancel it we need 1/4. So this gives me a 3/4 sine of 4x. What else do I have to have? Plus c, because we don't have any numbers to play.
How come the 3 out of the front didn't get an S?
Because it wasn't added. If it were added, if it were a separate term, then it would. Coefficients can just stay. Yes.
Okay, so like on this one, since there's no numbers by the thing,
Mhm.
that means we don't do the line.
Right. We just put the plus c instead. You're welcome. Number 11. What would I have to do before I can do that integral? Yeah, you have to clean these up first. You cannot do the antiderivative of x's being multiplied or divided. You have to clean it up. So on the top, that would give me a 4x squared plus 4x plus 1. Okay, but I still have x's being divided, so I can't do it yet. We have to do each one over the denominator. So this would be 4x squared over 5x to the 6th would be 4/5 x to the negative 4. Plus 4/5 x to the negative 5. Plus 1/5 x to the negative 6. That is probably the most common mistake, and it will cost you a lot of points if you just try to do the antiderivative from the beginning. You have to do the algebra, so it's written as x's added together. Now, when we do the antiderivative, we add 1. So negative 4 plus 1 is negative 3. So you need the reciprocal in front, which is negative 1/3. Can I go ahead and multiply it with my 4/5? This would be negative 4 over 15. And if you're not sure if you did it right, how do you check? Do the derivative and see if it works. Alright, the next one, if I add 1, that's negative 4, so I need a negative 1/4 in front. So that would become a negative 1/5. Okay, this one, if you add 1, that's a negative 5. So you need a negative 1/5 in front, so we just need the negative. 1 over 1/5 times 1/5 is 25. And then what do we need at the end? Plus c. Feeling okay? Number 12. How do I need to rewrite this? I actually, yeah, so if I bring it up top, if the exponent is negative 2. And I have to do that because I can't do the antiderivative with x on the bottom. So when I do my antiderivative, the 4 as a coefficient just stays. Okay, inside would stay the same. If you add 1 to the power, it's a negative 1, so we have to multiply by the reciprocal. Reciprocal of negative 1 is negative 1. But what else do I need? The derivative of the inside is 7, so you would need a, so we get a negative 4 over 7 times 7x minus 5 to the negative 1. And we're evaluating from negative 1 to 3. So because we have numbers plug in, we don't need the plus c. If you want, when you evaluate, you can pull that negative 4 sevenths out. If we put in a 3, we get 21 minus 5, which is 16 to the negative 1, so that means 1 over 16. Minus, if you put in negative 1, you get a negative 12, so minus negative would be plus. 12 to the negative 1 is 112. Oh, this is definitely not pretty mental math, is it? So, let's see, look at negative 112. For number 12, what do we have to do first? Yes, this is a quotient. We can't do the antiderivative as long as it's a quotient. A cube root is the same as saying 1/3, and we divide by subtracting exponents. So 4 minus 1/3, so 4 is like 12 over 3 minus 1 over 3 would be 11 over 3. Minus 2x, so 3 over 3 minus 1 over 3 is 2 over 3. Plus 4x negative 1/3. Alright, so we add them to the power. So 11/3 plus 1. So 11 over 3 plus 3 over 3 would be 14 over 3. So you need 3 over 14 in front times the 3 that's already there. So it'll give us a 9 over 14. This one. 2/3 plus 1 is 5/3. So it needs a 3/5, so that gives me 6/5 for my final coefficient. Oh, hold on. Is that a... No, never mind. Okay. Negative 1/3 plus 1 is 2/3. So we need a 3 over 2. So that gives me a 6. But are we done? No, now we have to evaluate from negative 1 to 1. Okay, so if you put in a 1, 1 to any power is 1, so we get 9 over 14, minus 6 over 5 plus 6. Put in a negative 1. Cube root of negative 1 is negative 1. Negative to the 14th power is positive. Cube root of negative 1 is negative 1 to an odd power be negative, so minus negative makes positive. This one will be positive. So we get that okay? So I put a lot of these on here. There's going to be a lot of them on your test. Make sure you're simplifying first. An absolute value. What do we have to do first? That's -2. So then we're going to integrate from -4 to -2, and from -2 to 5. Alright, if you put in something between -4 and -2, so if you put in a -3, 5 times -3 is -15, plus 10 is negative. The absolute value would make it positive, so it's the opposite of that. Opposite of a negative is a positive. If you put in something between -2 and 5, so maybe a 0, you get a positive, so the absolute value doesn't change. The antiderivative of -5x would be -5 x squared minus the antiderivative of 10 would be 10x. This one would be a positive 5 x squared plus 10x. And then we evaluate. -2 squared is 4 times -5 halves would be -20. Oh, sorry, -20. If you put in a -4, we get 16 divided by times 8, so -4. And if you do this, for the sake of time, because I would like to get through the rest, can you guys, you know how to evaluate from here? Alright. Initial value problem. What am I asking you to do? Antiderivative. What do I need to do before I can do this antiderivative? We need to multiply everything out. So this would be 16 minus 24x squared. Whoops. Plus 9x. This should be your 2x. So we have 32x minus 48x squared plus 18x cubed. So now we do the antiderivative. What is the antiderivative of 32x? 16x squared. Okay, 48x squared, so if you add 1, it's x cubed, so 48 times 1/3, 48 divided by 3 is 16. Okay, this one, add 1, so it's a 4, so 1/4, so 18/4 is 9/2. And what else do we have to have? Plus c. But I've given you the information to find c. We know that when we plug in -2, this whole thing has to equal 6. So if you put in a -2, so we get 264 plus c equals 6. So c is -258. So your final function is 16x squared and 16x cubed is 9/2 x to the 4th minus 258. And you can always check your answers by plugging them, or by doing your derivative. All right. Are we good? I know I kind of rushed through the simplifying at the end on those. You guys okay? Know what you're doing? Make sure, moral of that story, simplify before you do your antiderivative. We skipped the L'Hopital's because we did a few at the beginning of class, but let's run back there and see how many of those examples we can get through before the end, okay? All right, so we know to do L'Hopital's it has to be 0 over 0 or infinity over infinity. So we have to first check to see if we have an indeterminate form. 2 over a smaller and smaller number is going to infinity. E to the 0 is 1, so this is infinity minus infinity, which means it's indeterminate. We can't just figure it out. We can't do L'Hopital's because we have two fractions. So what's our strategy? Common denominator. So we take this one times the e to the x minus 1. We get 2e to the x minus 2. And we take the other one times x and minus 2x. Okay, so now we check to see. If I put in 0, e to the 0 is 1. So 2 minus 0 is 0. 0 times 0, so this is 0 over 0, which means L'Hopital's. What's the derivative of 2e to the x? Derivative of 2 is 0 minus derivative of 2x is just 2. What do we have to do for the derivative of the bottom? Derivative of the first times the second plus the first. Derivative of e to the x minus 1 is e to the x. So we have 2 e to the x minus 2 over e to the x minus 1 plus x e to the x. If we plug in, on the top we have 2 minus 2, which is 0. On the bottom we have 1 minus 1 plus 0. So it's still 0 over 0, so L'Hopital's again. Derivative of 2e to the x is still 2e to the x. Derivative of 2 is 0. Bottom derivative of e to the x is e to the x. The 1 goes away. What do we have to do for this piece? Okay, derivative of the first is 1 times the second plus the first derivative of the second. What can we take out of everything? So that would give me a 2 over, this was 2e to the x, so if I take out the e to the x, it's just a 2 plus x. So 2 over 2 plus 0, and we get 1. Number 2, what's infinity squared? E to the infinity is infinity. So infinity over infinity means we go straight into L'Hopital. Derivative of x squared is 2x. Derivative of e to the 2x. So you keep the e to the 2x times the derivative of the inside. What's the derivative of 2x? So we can cancel those 2's. Alright, so now it's still infinity over infinity, which means L'Hopital's again. Derivative of x is 1. Derivative of e to the 2x, we already worked out 1. This is 2e to the 2x. And now we can work it out. Because we have 1 over infinity, which goes to is that one okay? Let's try to do at least one. I think I can. Infinity to the -3, that's like 1 over infinity. So that's 0 times the natural log of infinity is infinity. So what do we do? Indeterminate form, we need it as a fraction. Which one would you move to the bottom? So now it's infinity over infinity, which means look tax. Derivative of a natural log is 1 over the argument. Derivative of x cubed is, what's the easiest way to clean this up? So we only have 1 over 3x cubed. You put in infinity, 1 over infinity goes to, and the last one, if you choose to check it, you should get e cubed for your final answer. I don't think I kind of get through it, but it's currently a 1 to the infinity, so this is when you have to do the natural